Okay, 1.3 part 2 is going to continue on with functions in the graphs, but really we're going to talk about something called the difference quotient. This is really going to have a lot of application in calculus, so it's like, since we're doing pre-calc, it's one of those things we're going to need to learn how to do now. And it's going to have something to do with something called limits and derivatives, which again, we'll talk about limits a little bit at the end of the year, but really calculus is all two things, derivatives and integrals. So we need to know how to do this in order to do half of calculus really. So our difference quotient, what that means is essentially it's kind of like slope, but it's going to look a little bit different. We're going to have f of x plus h minus f of x over h. Again, we just have this stipulation that h can't be 0, just so that we're not dividing by 0. Think about your domain restrictions that we've talked about in the past. So when you're doing this, the easiest thing to do is break it down into pieces probably. So we're going to look at f of x plus h, meaning we're going to take some given function, plug in x plus h, and then we're going to simplify it out. And the goal here when we simplify is that this h in the denominator should be eliminated. So really, it doesn't necessarily mean that all h's are going to be eliminated. It just means the one in the denominator is going to be eliminated. Okay. So if we look at our first one, I broke it down into two pieces here so we can practice this a little bit. I'm going to take all of my x's and I'm replacing them with an x plus h. And I'm going to include parentheses, and one of the reasons I do that is because there's this negative sign here and also because of the square. So to simplify this, I need to remember that this means x plus h squared, which means I have to FOIL, which is going to give me x squared plus 2xh plus h squared minus x plus h plus 3. Okay, I'm going to move this down a little bit. So to simplify this then a little bit further, I'm going to distribute my 2. So I have 2x squared plus 4xh. So 2x squared plus 4xh plus 2h squared. I'm going to distribute my minus sign here. So minus x minus h plus 3. Okay, now in this case, none of this can be simplified anymore, so we're going to leave it like that. Now when I do that, I'm going to bring this whole thing down. That was this piece right here. So I'm just going to rewrite that. 2x squared plus 4xh plus 2h squared minus x minus h plus 3. And then minusing my original f of x function. So I'm going to have 2x squared minus x plus 3 all in parentheses, because remember we're subtracting the whole thing. So what was that? 2x squared minus x plus 3. Minus x plus 3, all in parentheses, and all over h. Now, continuing on with that same piece, I am going to distribute that negative sign here. Sorry about that. Okay, there we go. So 2x squared plus 4xh plus 2h squared. I know this looks really messy right now, but it should simplify pretty quickly here. So minus 2x squared, this becomes a plus x and a minus 3 all over h again. Okay, if you pay attention to what happens here, we have a 2x squared cancels out with a minus x squared. We have a minus x cancels out with a plus x, and then we have a 3 cancels out with a minus 3. Now you'll notice, so that's gone. You'll notice what we have here is a 4xh plus 2h squared minus h all over h. And since every piece has an h now, these will cancel out. And only one of these h's cancel out. And this would become a 1. So we end up with 4x plus 2h minus 1, and this is what is called our difference quotient. And again, like I said, that's going to have a lot of applications in calculus. You're going to talk about a lot of slopes of tangent lines of functions, which is going to have to do with our acceleration and speed and velocity. Those of you taking those of you taking physics have probably seen some stuff like this as well already. essentially what you need to know is that some of the stuff in pre-calculus is like learning the alphabet. You never recite the alphabet anymore, but you need it in order to be able to understand how to write a paragraph, right? So this, in some ways, is kind of like your alphabet. We need to know how to do this in order to be able to move on to the next level of pre-calculus. Let's see. If we look at another example here, so we're going to have, I'm going to plug in my x plus h. So I'm going to do this one a little bit quicker. So I'm going to end up with x squared plus 2xh plus h squared again, plus, and this time I don't need the parentheses because it's plus x plus h plus 5. So on my f of x plus h piece, I'm going to have 2x squared plus 4xh plus 2h squared plus x plus h plus 5. And then I'm going to plug that in down here. And again, I'm going to do this kind of a little bit quicker so that we can see how things cancel out. And distributing my negative sign here, this would give us a negative 2x squared, and then minus x minus 5 all over h again. Oops. All over h. And let's see what cancels out. So we have a negative 2x squared should cancel out with that positive 2x squared at the beginning. We have a positive x is going to cancel out with our negative x, and a positive 5 cancels out with our negative 5. So everything without an h should cancel out if you do this correctly, which would leave us with 4xh plus 2h squared plus h all over h. And then since every term has an h, we can cancel those out. So this h, one of these, and this h, which becomes 1, cancel out with our denominator, which means we're going to end up with just 4x plus 2h plus 1. And I know that looks really similar to the last problem. That's because I grabbed a pretty similar equation. They're not all going to be just 4x plus 2h plus 1, or in the last case, minus 1. Okay, so like I said, has some calculus implications. Where you've seen this before, I talked about that a little bit at the beginning in terms of our slope of lines, and this is really where it's going to have a big application in calculus as well. We'll see you next time.